Okay, so in this video, we're just going to look at the different types of graphs that we can see actually with our polar equations. We're not going to graph these by hand. If we had more time, we would. But the first type, oops, is the circle. Ooh, why is this so large? Start that again. So the circle graph. And so we have two types of circles. These are always with sines and cosines, right? Everything always breaks down to sines or cosines. So a sine of theta. Basically, a is any non-zero real number. Okay. So as long as it's any real number, then we're good. So if we go to Desmos, so I have Desmos up here. I'm going to expand this just a little bit so we can see our graph. So I'll move this over a bit. So there is a settings part. So we can change it to the mode that we want it. Here is the coordinate grid, and then this is the polar graph grid. I have it on projector mode so we can actually see it a little bit easier. So here is one of the equations we have. So this is your cosine. So if I click on that, so notice that it's a lovely circle. It's the symmetry with the x-axis, right? As I move my a larger, notice that it moves out towards the right. As my a flips to the negative, right? Notice that it flips onto the other side of my graph. Okay, and that's just when your a. Let's change it back to 1-ish. That's close enough. If my sine, so if cosine, the circle is kind of towards your x-axis, sine is the opposite. It's around the y-axis. So again, as a gets larger, notice that the circle is going to move upward. As your a gets negative, it's going to open up downward. And again, it always starts at that origin. So bring it back up to 1. Okay, so that's your circle, right? Pretty easy and basic. Okay, the next graph that we see here, we see r is equal to a parentheses 1 plus the cosine of theta, or 1 minus the cosine of theta. So let's take a look at this one. So notice that as my a gets larger, right, or smaller onto the other side, this graph is known as a cardioid, right? This is what's known as a heart-shaped graph, right? So here's two cardioids together, and it makes a fun little intersection. We can interchange that with sine. So if I take this away, so again, when I open it like this, notice that it's kind of opening down. This definitely kind of looks more like a heart. And now here's the heart upside down. Okay. As I can change my a value. So if I come back over here, and so let's write this one out. So this one's known as a cardioid, right? So this is your heart-shaped graph. And so again, your r is equal to a parentheses 1 plus or minus the cosine, or a parentheses 1 plus or minus the sine of theta. Again, a is any non-zero real number. Okay, so one graph kind of opens to its side, and one graph opens up and down. Okay, the third type of graph we are going to see in just a second is known as a limacon. Okay, this one is kind of like a cardioid, but with an inner loop at the pole. So basically at the origin, and again, as long as a is less than b. So we might have something that looks like this: a minus b cosine of theta, or r is equal to a minus b sine of theta. So let's see kind of what this one looks like. We're gonna bring this back over here. So let's take this one away. So let's add in. So there we go. So notice that this is your cardioid. So again, as long as my A value is smaller than my B value, so my B value is a 2.3 and my A value is negative, right? I can actually, I don't need these anymore. So I'm going to close some of these off. Okay, so if I change my A value to, let's change it to 2, oops, not a 2, to a 2, zoom in, it still has a loop because notice that your B is still smaller, still larger than 2. So if I change mine to a 5, right, notice that the loop gets a little bit bigger. And then if I change this here, right, for sine, my graph is flipped upside down. Okay, so again, it's like a cardioid. We see the cardioid little dip right there, but then it just has an inner loop on the inside. Okay, it can be plus or minus. I could add that. So I'm gonna take that away. So then one of the last, or second to last, or I should say last, one that we're gonna deal with, I should say, our graph is an n-leafed rows. Okay, so notice what I mean by that. So I'm going to pop this up. So notice that here's a lovely flower. Okay, so here's our cosine with flower with n is equal to 3. And again, my A value is just a 2. Notice that when I put it as 5, so there's 5 petals, so to speak, 1, 2, 3, 4, 5. If I say 7, notice that there are 7 now. So 1, 2, 3, 4, 5, 6, 7. Right? What happens if I put 4? Do you think there will be 4 petals that show up? Ooh, nope. There's 8. 1, 2, 3, 4, 5, 6, 7, 8. What happens if I put a 2 up? Ooh, 4 petals. So if I want 4 petals, I need to put a 2. So if I want 8 petals, I have to put a 4. So, so anytime you have an odd number, that actually tells you how many leaves you're going to have. And it doesn't matter if it's cosine or if it's sine, right? As long as your n value is odd, then you'll have the odd number of leaves. If it's even, right, then you'll have double leaves. So come back over here. Let's add that one. Oops. Let me erase this part right here. This would be number 4. So this is called the n-leafed rows. It's very pretty. So r is equal to a cosine of n theta. We can say r is equal to a sine, or n of theta. So if n is even, there are 2 times n loops. And if n is odd, there are n loops. Okay, so these are just really fun graphs that we can graph by hand if we so want to. Okay, so those are your different types, just a couple of different types of polar graphs that that we can actually do and use and draw using our polar. All of these would be our polar coordinates. All right. So just something fun and interesting.